Welcome back, Algebros. Our next adventure in the land of quadratics involves something called factoring. This is something that goes beyond even the scope of quadratics, and we could spend an entire year talking about nothing but factoring. But we're going to keep it simple, and we're going to break it down into multiple tiny bits so that way we understand it every step of the way. Note, when we say factoring, there is the word factor in the middle. And if you remember some basic facts from maybe 3rd grade, you know that factors are the things you multiply together. So these things here are the factors. And that has a play in this. Because when we talk about something called the factored form, which you might have seen before, that's usually the multiplication of two different things, maybe two binomials, for example. And that multiplication is the dead ringer giveaway. But before we jump right into it and figure out how we get there, where we're going, and how we get there, let's talk about some basics. The first one, we need to talk about how we find a greatest common factor from a set of terms. You've already seen this way back in the day, how we find greatest common factors, or GCFs, for numbers. For example, this one right here with 10 and 25, you make a list of the factors. Some of you might have done T-charts in the past. You list out the factors, you pull out the biggest one. But how do we do it when we have variable terms in the mix? We're going to find out. The answer is as follows. We yoink the GCF of the numbers, as we've done before, and then we slap on the lowest exponent of each kind of variable. You may be confused by the slang, but let's go over it together. So let's see this. In this example right here of 4x squared and 2x, the first step is to focus exclusively on the numbers. So in this case, I'm working with 4, and I'm working with 2. This is a fairly simple GCF problem. The GCF of 4 and 2 is nothing more than just 2. Remember that the factors are the ones that are lower, not the multiples. Don't get that one mixed up over here. Now, what do I mean by the lowest exponent? We now turn to our variables, the x squared and the x. Remember that when I don't have a visible exponent over something, we immediately assume that it's 1. So when I see x squared and x, we can immediately assume the lowest exponent here is the one with 1. So in this case, the lowest exponent, or in other words, the GCF of the variables, is going to be nothing more than x. Might be something to get used to. In general, if we have the GCF of x and x squared, that's just going to be x. Personally, that's algebra fairy worthy, because that's important. So in that case, it's nothing more than the GCF of the numbers and the GCF of the variables multiplied together. The GCF of the numbers we found to be 2. The GCF of the variables we found to be x. Okay? Nice and simple. Let's start expanding that. So, we've already talked at length about the variables and how we find those GCFs. This is the most basic situation of that with x squared and x. Both coefficients are 1, so we don't really need to worry about that first part of finding the GCF of the numbers. Instead here, I'm going to find the GCF of the variables, and as we saw here with our algebra fairy related hint, the GCF of x and x squared is nothing more than just x. Nice and easy. Let's do the next one. 3x and 9x squared. So let's go with our first step, the GCF of the numbers. This one will involve all of the steps now. 3 and 9. That GCF, fairly simple, is just going to be 3. Mostly because 3 is just a factor of 9. A little bit of a wink wink there. Next is the variables, x and x squared, and we know the GCF of the variables, thanks to our algebra fairy related hint, is just x. So the overall GCF is now going to be their multiplication, 3x. No, it's never going to be the addition. Because remember, when we talked about factors, we are exclusively talking about multiplication. Let's do it again. 7 and 2. Those don't have an obvious GCF. So in that case, if there's no other common factors, remember that they always at least have a factor of 1. And then for the variables, x squared and x, we know that GCF is going to be x. Just going to circle our answers over here because it's good practice. Next up is 4x squared and negative 6x. Here's our first little bullet point note. If we start having negatives, as we do right here, if there's only one negative, the GCF is going to be positive. But if there's two negatives, the GCF will be negative because the negative counts as a common factor. So in this case, 4 and negative 6, there's only one negative, so the GCF will be positive. So now 4 and 6, their GCF is just 2. Then x squared and x, we know that to be just x. Here's the counterexample to that. Negative x squared and negative 5x. I've got negative, and I've got negative, so now I have to pull out a negative. Next up, the variables. X, actually, hold up. 5 and negative, and just 1 is just a 1. We don't need to worry about that. Now we do the variables. X squared and x, we know that's just x. A lot of it is a very visual exercise that really just flexes those old school multiplication facts. And I want you to embrace that. I think it's a good thing to do that. Next up, 12x squared and 18. Notice here, I just have 18 with no x. Here's a little bit of another hint, or a note, as I will call it. Remember that any number that has an exponent of 0 is nothing more than 1. So if you don't see a variable, so no variable, means that the exponent is 0. And that's the case right here. It's as if it's 18 times x exponent 0. Meaning that the lowest exponent is not 1 anymore, it's just 0. Meaning that we don't put any common factor for the variables, because in that case, it's just 1. But don't worry about that too much. Now we just worry about our numbers, 12 and 18. We can list out some factors there and find out that the GCF is 6. I haven't been putting too much focus on finding the GCF of the numbers, but that's because that's something you've seen before, way back in like 6th and 7th grade. So I'll leave that as an exercise for you, or up to you, if you realize, oh wait, I don't remember how to do these. I got plenty of resources and extra practice for you as well. For the rest of these, I leave these as you tries for you. Can you factor your way out of this mess? I sure hope you can. We continue our factoring adventure next time.